Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Syafiqah binti Abdul Hamid, and now I'm going to present the experiment with my partner, which is Nur Sahira binti Effendi. Okay, next, the topic for our presentation, which is experiment 1, is a shading profile. Okay, first we will talk about the objective of the experiment. The objective of the experiment is to assess the shading profile at a particular site and also to determine the irradiation at that site. Next, before we do the experiment, we need to know what the equipment that we need to use in the experiment. Okay, the first equipment is the sunglasses that can use to protect our eye from the small particle. And then next we need to wear the hard hat that can protect our head. Okay, the third equipment is the solar pathfinder set. And then fourth is the solar pathfinder chart. Okay, and then we also need a compass in our experiment to know the location of the site. Okay, for the procedure of this experiment, first step is we need to insert the rounded end of the tripod legs and then pull out the leg of the tripod and set up the tripod. Okay. Next step or second step, integrate it with the solar pathfinder base and put the instrument that consists of compass and also the lever. Okay. For the third step, put the solar pathfinder chart onto the instrument, and before that we need to check whether we use the correct sun chart diagram based on the latitude of the site. Okay, for the fourth step, we need to make sure that the bubble is on the center of the lever by adjusting the tripod legs. Okay, for the fifth step, put the solar pathfinder put the top of the solar pathfinder and put it correctly. Okay, lastly, we can use the pencil to sketch the phrasing of the shading, or else we can also use the camera to snap the picture of the shading profile. Okay, that's all from the procedure of the experiment 1.
Okay, next we go to the next part, which is result and data for this experiment. This is the data and result that we got from the experiment, which is we have 3 different row data 1, row data 2, and row data 3. For each row data, we try to find and determine the total annual solar irradiation for January and also for the entire year in unit kilowatt hour per meter square and also megajoule per meter square. And then we also try to find the average daily peak sun hour for the month and also for the entire year. Okay, from this data and determination, we can find the better shading profile between the 3 row data. Okay, now I will continue with the next part, which is discussion. Then in this part, I will tell more detail about this experiment and about the solar irradiation. Okay, first we need to know what is meaning by solar irradiation. Okay, solar irradiation is the intensity of solar energy at a point observation. So analysis of shading generated by surrounding obstacle is necessary because shading should be reduced as much as possible since shading has a significant impact on solar irradiation. So if there is only one cell shading in a PV module, the power output may be 0. And then the shading effect caused by trees, nearby buildings, moving clouds, and many other factors will be an impact on the performance of PV modules. Okay, in this experiment, solar pathfinder was used to calculate the shading factor for the site for analysis. It was also compute how much solar radiation was received at the place. To get the best possible sun radiation for this experiment, it's critical to locate the location with the least amount of shading. Okay, for your information, the lab manual provided the monthly sun irradiation. So to obtain practical experience with the tools, we can still do the experiment on site. So the percentage shading was computed using the solar pathfinder chart. And then we can use the formula for calculating shading factor, which is we can use the formula below, which is 100 minus percentage shading per 100. For your information, the pencil tracing may cause the percentage shading to differ. So the slight shadow may have an impact on the shading as well. The value state would not be very accurate if we were only use our eyes. Okay, after we done the shading factor, after we calculate the shading factor, we need to calculate the value of H side by using the formula shown in this slide. And then after that, the solar irradiation also can express by using megajoule, which is mj, due to its large energy quantity. So that by using the formula given in the slide, we can determine the solar irradiation in megajoule. As I mentioned before this, for this experiment, three solar pathfinder chart data sets are provided. In data 1, data 2, and data 3, all information and calculations were recorded. The annual PHY carried from data for table 1, table 2, and table 3 that we can see from this slide at the point number 1. After we comparing the information from the three tables, the site in the table 3 has the most sun irradiation because there is no shading there. So the location of table 3 would be ideal for installing a PV array system because there will not be any shading to prevent the PV system from performing well. Okay, we also do the comparison between table 1 and table 2. And then we can conclude that table 1 has more sun irradiation than table 2, which is due to site at the table 2 having more obstacles than table 1. So therefore, site for table 1 is greater to table 2. The site in table 2 is the least suitable of the three investigate location to install a PV array system because it has the largest shading factor. Next, we go to the precautions step, which is during the experiment, there are a few safety measures that may be done to ensure that the data collected is highly accurate. First, the solar pathfinder red compass needle has to be facing the north. And then second, to prevent incorrect charge shading, we need to avoid self-reflection on the solar pathfinders. And then next on the solar pathfinder, the bubble must always be in the middle. And then the last one is we need to confirm that the appropriate solar chart is being used before doing a shading profile assessment. So the latitude must be indicated on the appropriate solar chart for measure in order to determine the shading profile. Now we go to the last part, which is conclusion. We can conclude that the shading profile was considered when determining how many solar irradiation was accessible for a specific site. Solar pathfinder charts were used in this experiment. Calculations were made using the experiment's data and findings that were given to the students. Using the data 1, 2, and 3, the yearly PSH can be found because the shading on the solar pathfinder. Thus, according to the findings of this experiment, the location solar irradiation is higher when there is no shading than it is at a site with shading on the solar pathfinder chart.